Imagine you have a network of temperature sensors across a factory floor. Some decisions, like turning on a fan when it gets too hot, must happen instantly, while others, like analyzing trends over months, can wait for cloud processing. This lesson dives into edge versus cloud computing in IoT, helping you understand where computations happen, how latency and reliability change, and which approach fits which scenario. By the end, you'll know not only the theory but also practical strategies for designing IoT systems, deciding what logic stays local on the ESP32 and what goes to the cloud for analysis or reporting. These insights are essential for building responsive, scalable, and reliable IoT solutions. Edge computing means performing data processing directly on the IoT device or a nearby gateway rather than sending everything to the cloud. Think of an ESP32 controlling a motor based on a temperature threshold. The decision must happen instantly, without waiting for internet communication. Real-world projects often combine multiple sensors, and processing data locally reduces network load, improves responsiveness, and increases reliability when connections drop. Edge computing is particularly useful for critical real-time tasks, offline operation, and bandwidth-limited environments. Consider the trade-offs. Local processing may require more device memory and careful coding to ensure efficiency, but it guarantees faster action and reduced latency. Cloud computing involves sending IoT data to remote servers for storage, processing, and analytics. Picture hundreds of environmental sensors streaming data to AWS IoT Core. The cloud aggregates, analyzes, and visualizes trends, triggering alerts or long-term insights. Cloud approaches excel at large-scale monitoring, historical data analysis, machine learning, and centralized management. The trade-offs include higher latency and dependency on reliable internet, but you gain almost unlimited compute resources and easy integration with dashboards, APIs, and analytics tools. In practice, most commercial IoT solutions combine cloud processing for non-critical tasks and dashboards while leaving immediate decisions to edge devices. Here's a practical comparison to help decide which approach fits your IoT design. Edge computing excels in low latency, offline, and immediate decision-making scenarios, while cloud computing shines in scalability, complex analytics, and centralized management. In real projects, hybrid approaches often dominate. Critical logic runs at the edge, while heavy processing, reporting, and storage are delegated to the cloud. Visualize your workflow. If your system must respond in milliseconds, put it on the ESP32. If you need monthly trend analysis or multi-site dashboards, use the cloud. Understanding these trade-offs helps you architect robust, responsive, and efficient IoT solutions. In real ESP32 projects, I often split responsibilities. Time-critical sensors, alarms, and actuators are handled locally, while logging, reporting, and machine learning happens in the cloud. When designing, ask, can the device make this decision alone? Does it need historical data? How critical is latency? Use MQTT or HTTP to communicate between edge and cloud efficiently. Consider caching data locally in case the network drops. Small design choices at this stage prevent bottlenecks, ensure safety, and improve user experience. Reflecting on past deployments, I've seen systems fail when latency-sensitive tasks were cloud-dependent, something that could have been avoided with proper edge logic. Across IoT applications, balancing edge and cloud computing is crucial. You've learned the key differences, practical trade-offs, and hybrid strategies. By applying these principles, you can design ESP32 systems that respond instantly, scale effortlessly, and remain reliable even when networks fail. These insights help you make informed architecture choices, select the right communication protocols, and optimize both device-level and cloud-level operations in your IoT projects.